this is the part 2 of the Thanksgiving assignment. Alright, so let's try to look into this question together. So here we have at the beginning of 2010, and then it goes on. Now, at the beginning, this implies when t is equal to 0, which you will see right over here. Now, landfill contains 1,400 tons. Now, so then this will be the initial value which we'll be looking at. Now, an increasing function given blah blah blah. Now, here we have dw dt. This is the derivative of w in terms against t, and that has been described in this way for the next 20 years. First, use the line tangent to the graph of w at t equals 0. So, once again, in order for us to look at A, we're looking at tangent line. And we've been needing a point. 0, comma, y value in this case, w value for that matter, will be 1,400. Now, another thing that we will be needing is the slope, m. A slope can be found by w prime, which we will be using this expression. 1 over 25 times 1,400 minus 300. Now, once you calculate this one, you will realize that that's equal to 1,100 divided by 25, which will be equal to 44. Now, then, by using that, we will be able to figure out y equals 44. Instead of y, we should write down, I guess, w. (44t plus 1,400). There is the equation of the tangent line. Now, they want us to approximate when t equals 1/4, given the setup. So when t equals 1/4, then what we need to do is simply plug in 44 times 1/4 plus 1,400. Now, then this becomes 1,411. Now, obviously, the unit in this case, as it was mentioned, it will be tons. Alright, that was equal to A. Number B, find the double derivative. How are we going to find the double derivative? It will be simply dw dt. You're going to take the derivative of that. Then in this case, what we end up getting is 1 over 25. The coefficient stays. We'll simply end up getting derivative of w minus 300, which is equal to dw dt. And this will be now equal to 1 over 25 times 1 over 25 w minus 300. Then at the end it becomes 1 over 625 times w minus 300. Now use this to determine whether your answer in part A is an underestimate or overestimate. Now, in order for us to do that, we have to use the concavity. Now, at that particular point, meaning one point that we know for sure will be this. In that case, what we end up getting is this. Second derivative now will be equal to 1 over 625 times 1,400 minus 300. This is clearly greater than 0. That means we are looking at positive concavity with positive slope. If I were to draw a sketch, what's going to be happening is, if this one were to be the straight line, the tangent line, then about that particular point, whatever the, let us assume that this is the point, In order for us to have the positive concavity, that means graph would look something like this. Obviously, our approximation through the tangent line is the under approximation than the actual value. So therefore, our answer is under estimate. All right, let us move on to the next question. I believe this is number 21. Okay, here we have f is continuous. How are we going to show that f is continuous? That means we are looking at f of 0 must be equal to the limit of f of x as x approaches 0 also has to be equal to each other. F of a, because f of 0, since 0 belongs to the upper portion of the piecewise function, and that will be equal to 1 minus 2 sine of 0. Now, but in order for us to evaluate this, we have to look at the limit of the function as x approaches 0 from the right has to be equal to the limit of the same function as x approaches 0 from the left. From the right, that means we are looking at the values that are a little bit greater than 0, which means right here, second expression. This one has to be equal to, in order for us to get that, we'll be looking at e to the negative 4 times 0. Has to be from the values that are a little bit smaller than 0, which will be upward value. 1 minus 2 sine of 0. Now, first and third, we will realize that the value will be equal to 1. And even the middle one, because the exponent will be equal to 0, the whole entire expression will be equal to 1. Since all three values are equal to each other, therefore it is continuous. Now, number B. We need to express the derivative of f as a piecewise defined function. Now, and after that we need to figure out where everything is equal to negative 3. So, derivative wouldn't change the domain. So first, the derivative of 1 minus 2 sine of x becomes 1 minus 2 cosine of x, where x is less than or equal to 0. But the bottom one becomes negative 4 times e to the negative 4 x. In this case, that's when x is greater than 0. Now, but we are looking for x value where its derivative is equal to negative 3. Since we do not know where the value of x would have been, we have to try for both of them. So here it goes. Let's look at the first one. 1 minus 2 cosine of x. Can this be in fact equal to negative 3? Then by subtracting, so we end up getting negative 2 cosine of x has to be equal to negative 4. Then cosine of x is equal to 1/2. The next value, in this case, we are looking at simply positive and negative. We're looking at, in terms of positive values, we are looking at pi over 3. And then, if x equals negative, x has to be equal to negative pi over 3. Now, after that, we'll be continually increasing this value by the pi's plus k pi, where pi is some sort of not pi, actually 2k pi, where k, because every 2 pi it will repeat the same thing. K is an integer. Here, this will be the same thing, plus 2k pi, where k is an integer. Now, but which one will be our answer? Because this is based upon x being equal to x being negative, so only thing that we will accept will be the bottom answer right over here. Now, but in this particular case, we have to see if we can also get the upper one when x is positive. And in order for that to happen, negative 4 e to the negative 4x has to be equal to negative 3. And in this case, we get to realize that e to the negative 4x will be equal to 3/4. Now, to get rid of this one, we'll end up getting e to the 4 to the x power becomes getting the reciprocal, which is 4/3. And by putting the ln, we'll end up getting ln of 4x has to be equal to ln of, oops, my bad. By taking the ln and e cancels out, ln of 4/3. But to try to find out the value of x by itself, x will be equal to ln of 4/3 divided whole thing by 4. That becomes another value. Now, is this positive? Yes, because 4/3 is greater than 1, so ln of 4/3 must be positive, and that will become our answer. So that's another value right here. Now, let us move on. Here, we are looking at a similar expression as before. Is R continuous? Once again, in order for us to see if something is continuous or not, what we need to do is R of phi has to be in fact equal to the limit of R of t as t is approaching 5. Now, R of 5 belongs to the upper one, where we will end up getting 600 times 5 divided by 5 plus 3. Now, that's 1. In fact, is that equal to this value when t is greater than 5, then we end up getting 1000 e to the negative 0.2 times 5. Let us try to evaluate these two values first, because limit as t approaches 5 from the left would have been same as this one. So then here, what we end up getting is so here we have 600 times 5 divided by 8. 375, that's what we end up getting for the first one. But once you calculate this one, this will be 1000 divided by e, and you will realize that they're not equal to each other. So therefore, it is not continuous. Now, number B. Average rate is basically same as the slope. Now, that means average rate here becomes r of 8 minus r of 0 over 8 minus 0. R of 8, because 8 belongs to the bottom section, becomes 1000 e to the negative 0.2 times 8 minus r of 0 belongs over here, which is equal to 0. Divide the entire thing by 8. That becomes our average rate. Then once you do this one, you will realize that the value will be 1000 over e to the 1.6 times 8. That becomes our final answer. But 1008 can cancel out, becomes 125 over e to the 1.6. Alright, now let us look at number 3. We want to find the derivative when t is equal to when t is equals to 3. Now, see r prime of t in this case will be equal to, we have to take the derivative of in each case. But the thing is, we don't have to worry about the first one because 3. Actually, we have to worry about the first one, not the second one, because 3 is within this domain. So let us try to find the derivative of the first one. 600t over t plus 3. So when you take the derivative, the denominator square, so t plus 3. And then the first one becomes 600 times t plus 3 minus 600t times the derivative of the bottom, which is simply 1. Then once you calculate this one, what we end up getting is this. This becomes 600t and 600t cancels out, so we have 4800, which is the product between 608 and then t plus 3 square. Since we are looking for our t is equal to 3, once you plug in 3, then we will end up getting 4800 divided by 36. Because 3 plus 3 squared becomes 36. Now, by dividing it by 12, then we'll end up getting 400 over 3. Now, then unit here in this case, originally R was measured in liters per hour. Derivative of liters per hour becomes liters per hour square. And meaning of this one becomes the rate of change in whatever R was. Here R is the rate of drainage. So rate of change in rate of drainage. All right. And this becomes our number 23. So here let's try to look into this one together. Differentiable function known that this much. Now find the x-coordinate of the critical points of f, where critical points, as soon as you see the word critical points, then we are looking at first derivative has to be equal to 0 or do not exist. One of those two. Now, since they gave us the first derivative, as a 4 minus x, and then x to the negative 3 power. Now, of course, this will be equal to 0 when x is equal to 4. But this will be do not exist when x is equal to 0, because this becomes the denominator. Now, then once I set up these two values, use the number line and try to find the intervals here. If I were to plug in -1, I realize that the numerator becomes positive while the denominator is negative, so we will end up getting negative. From 0 and 4, if I were to use the value 1, then numerator and denominator will be positive, hence it becomes positive. If I were to plug in the value after 4, such as 5, then numerator becomes negative, but denominator is positive, therefore we end up getting negative. So therefore, about 0, what we will end up getting but the thing is, for x has to be greater than 0, so this cannot be included here. Only value we are looking at is right here, positive and negative, so therefore 4 must be relative maximum. Alright, number B. Find all intervals in which the graph f has concave down. Concavity is found by the second derivative, so we're going to take the derivative of this one more time. Then it becomes 4 minus x times the derivative of x to the negative 3, which becomes negative 3 x to the negative 4th power. And then plus x to the negative 3 power times the derivative of 4 minus x, which is equal to -1. Then what we can do is we can factor out whatever is common. And here we have x to the negative 3 power. Then we have negative 3x has to be multiplied here and here, then we end up getting negative 12x plus x to the -1 is still there, and this one becomes negative x times x to negative 3 to x to the -1 power becomes simply 3. And then actually we have to include -1 over here. So once we have done this one, we have to set this one equal to 0. Or if you have to simplify this one further, what we'll end up getting is we'll have x cubed on the denominator, and on the numerator we have -12 over x plus 2. Now, this can be either equal to 0 or do not exist. When it's equal to 0, the numerator has to be equal to 0, so we will realize that x has to be equal to 6. Now, it doesn't exist if x equals 0. So once again, 0 is not part of our domain, so we wouldn't worry about that. We have to only worry about x equals 6. So here we have, for the second derivative, we have 6, and we have 0. It has to be greater than 0, and then 6 divides the interval. So if I have to plug in 1 as a testing point to the second derivative, we'll end up getting negative is on the numerator. Denominator is positive, so we'll have negative point. And if I have to plug in the number that's greater than 6, such as maybe positive 12, then this portion becomes negative 1 plus 2 becomes positive, and then denominator is also positive, so we would end up getting something like this. Concave down, then in this case, is this area. So our answer becomes 0 all the way up to 6. That becomes our answer. Alright, that's it. I'll put up another video later, and have a nice day. Bye-bye.